So what if the next great invention wasn't made by a human at all? What if it was the last invention humans ever needed to make? That's the wild idea at the heart of the technological singularity. Now, it might sound like something straight out of a sci-fi movie, but it's a topic of serious debate among some of the world's top thinkers. So let's break it down. What is it really, and just how close might we be?
This quote from the mathematician I.J. Good all the way back in 1965 just nails it. It really sets the stage for what we're talking about. It perfectly captures the massive, world-changing stakes of creating an AI that can actually surpass our own intelligence. See, this isn't just about a faster computer. It's about a potential intelligence explosion that would leave our human brains in the dust.
Okay, so that word singularity, it gets thrown around a lot, right? But what do the scientists and researchers actually mean when they use it? To really get a handle on this, we've got to break down the two main definitions that are at the center of this whole conversation.
And right here, you can see the huge difference. On one side, you've got the weak singularity. This is a future that, we can at least try to wrap our heads around. An AI that's just flat out smarter than the smartest person. But then, you've got the strong singularity. And this is a completely different beast. It describes a theoretical point where intelligence doesn't just get better, it kind of breaks the rules of physics as we know them, accelerating towards a practically infinite level. So we're not just talking about smarter tech, we're talking about a fundamental break in the entire pattern of progress.
So how in the world could something so extreme even happen? Well, the core engine behind this idea is a feedback loop, a really powerful one. They call it the intelligence explosion. Let's take a look at how the model works.
It's really modeled in 3 stages. Step 1 is basically where we are right now. Humans are in charge. We're building the AI. And yeah, progress is fast, it's exponential, but it's a curve we can still kind of track. Step 2, though, that's the game changer. That's the tipping point. This is when an AI gets good enough to improve itself, to design its own even smarter successors. And that kicks off this crazy, recursive self-improvement loop. Which brings us to step 3, the explosion. That feedback loop could flip the script from that familiar exponential growth to something called hyperbolic growth, a curve that pretty much just goes straight up.
And this just shows you the difference perfectly. On the left, that's the classic J-curve of exponential growth. We're all familiar with that. It gets steeper, sure, but it's still a curve. But on the right, well, that's the hyperbolic explosion. I mean, look at that. It doesn't just get steeper, it rockets towards a vertical wall. It's a totally different kind of event.
Now, what's so cool about this graph is how these two types of growth look on a logarithmic scale. That red line, the exponential one, it's just a steady, predictable, straight line going up. But check out the blue line. That's our intelligence explosion. For a while, it looks pretty much the same, but then it hits that crucial tipping point where it suddenly just gives up on being a gentle slope and shoots for the ceiling. That little bend right there, that's everything.
So if, and it's a big if, this feedback loop kicks in, how fast could this whole explosion happen? Well, while it's all theoretical, one model that researchers looked at came up with a pretty startling number, just 12 years. Okay, hold on. That number is obviously a bombshell, so it's absolutely critical we understand the fine print here. This is an illustration, not a prediction. Let me say that again, not a prediction. It's based on some very specific and very simple assumptions. Like, it assumes there's a straight line relationship between how smart an engineer is and how fast AI grows. And it uses a rough guess that we humans are about 100 times smarter than today's AI. You change either of those numbers, and that 12-year figure goes right out the window. It's really just a thought experiment to show how fast a feedback loop could potentially move.
All right, let's step away from the pure theory for a second. What's happening in the real world right now that's actually pushing us towards this kind of future? Let's look at the accelerators, the things that are hitting the gas pedal.
The research really points to 4 major technological frontiers that are pushing us forward. The first one is obvious, right? It's the insane pace of AI and machine learning itself. But all that AI needs some serious horsepower, which is where quantum computing comes in. It could provide the raw processing power needed for an intelligence explosion. Then you've got brain-computer interfaces, which might start to merge our minds with machines directly. And finally, things like nanotechnology and 3D printing could build the actual physical hardware this future AI would need to operate in the real world.
But it's definitely not a clear road ahead. Let's pump the brakes for a minute and look at some of the pretty big roadblocks and speed bumps that could slow this whole thing down, or maybe even stop it from happening at all. Yeah, there are some powerful brakes on this process. First, on the tech side, we're still wrestling with the black box problem. A lot of the time, we don't fully get how our AIs work, which makes building one that can improve itself incredibly hard. That uncertainty feeds right into the second brake, huge ethical and societal fears. We're talking about everything from mass job loss to autonomous weapons. And those fears can directly lead to the third break, governments and companies getting nervous and pulling back on investment. And all of that can build up to the final roadblock, tough regulations and political chaos that could just stop progress cold.
So what happens when you have these incredibly powerful forces pushing the accelerator and these massive forces slamming on the brakes all at the same time? Well, you get a future that is fundamentally unpredictable, a total wild card.
And this brings us to a perfect concept for this whole discussion, the butterfly effect. You've probably heard of it. It's from chaos theory, and it perfectly captures the problem we have with trying to make predictions here. In a system as complicated as global tech development, one tiny change, a new algorithm, a single new law, one breakthrough in some lab could have gigantic, unforeseen consequences for the entire future.
And just to make it even messier, randomness itself adds a whole other layer of fog. The research shows that high volatility, big leaps forward followed by long periods of nothing, can actually make a hyperbolic trend look like normal, steady exponential growth, right up until the very last second. And here's the paradox. That same randomness could also just keep disrupting the feedback loop, stopping an explosion from ever really getting off the ground.
And so that brings us to the ultimate question. When you stack up those powerful accelerators against those really significant brakes, and then you throw in the profound uncertainty of the butterfly effect and just pure, dumb randomness, what are we left with? Is an intelligence explosion of this kind just bound to happen? Is it something we can, or even should, try to prevent? Or is our technological future just too complex, too chaotic, to ever truly predict?